All right, so this week we are going to talk about Python Dateutil, and I will share my bash prompt, my terminal window here. And this is, let's see, it is for helping deal with Python date utility. So we'll start from the absolute beginning here with installation because the name of the project is not necessarily intuitive. So it's pip install Python dateutil. And it also installs 6. And if you have PyTZ installed, it will take advantage of that. I'm not going to go into the time zone features because we don't have all day. So I won't bother to install PyTZ. So there are several, at a high level, there are 3 main classes for dateutil. The first one is parser. The second one is relative delta, and the third one is rule. So we will start with parser. And if you want to follow along, oh, where's the chat? Chat. There we are. I just posted in the chat for the Zoom meeting the documentation for the parser. Okay. So to use it, we go import, and actually I'm going to do from dateutil till import, and we'll do parser relative delta and rule. Now these are modules, so it's classes within these modules that we're going to use. So we'll start with parser. Now parser is a generic datetime string parser. If you're familiar with Python's datetime parser, that expects an explicit an exact format you cannot deviate from. Parser is dateutil's parser is more generic, so it allows you to take an arbitrary string and with some restrictions turn it into a datetime object. So let's look at an example here. So we can parse this date right here. And actually we need to go parse.parse like that because it's the parse function in the parser module. There are some objects where you can make a customized parser object and have a bunch of the settings built into every time you call parse, but we're not going to get into that. So this, so without specifying a format, we can do this. Oh, parser. Typing is hard. There we go. And we get back the datetime string that we expect. Now, there are some assumptions that parse makes out of the box. Like, for instance, it assumes that the month comes before the date. So we have a format here of year, month, date. So we can do something like this. -2012, and it does the right thing. Now, if we flip-flop the 19 and the 1, it will still do the right thing, but you'll note that, of course, it's ambiguous. So what if we have something like this? Well, it's going to assume that the month came first. So we can change that and say, well, we're in North America, English speaking, so we can say day first equals true. And then it will say, okay, yeah, the first value when it's ambiguous like this, we're going to assume that the day is first. Let's see. Now, if we don't specify enough digits for the year, then it's even more ambiguous. So we say, okay, so this assumes, let's see, where is it? This assumes, because this assumes month, day, year, we can also do year first equals true. And that will say that the first thing that we have, so this is the year, year, month, day format. And this is strictly for handling ambiguity. Now we also have fuzzy. This is fun. So we can do a string like this. Fuzzy tells it to ignore. Let's see if I get the quotes in there. Yes, I did. Fuzzy tells it to ignore. Oh, it's using real quotes. Hold on. To ignore tokens that it doesn't recognize. Oh, typing is hard. So we can do something like this. Fuzzy equals true. And it will do the right thing. Now you'll notice that it also interpreted January properly. So we can do without fuzzy. We can take fuzzy out. We can do something like this, and it will do the right thing. So it recognizes names of months and then if you turn fuzzy on, it will ignore stuff that it doesn't think belongs. Now, the trick with fuzzy, though, is fuzzy is probably a little bit too forgiving. So if I go like A, B, C, 1, 2, 3, fuzzy basically says, so if I try to do this, it's going to say, I can't make sense of that. But if we specify fuzzy, fuzzy always returns a result. Like that. And there's rules for how fuzzy like throws things out and includes them. But basically what it is it looks for things that it recognizes and tries to turn it into a date. That's what fuzzy does. And usually you don't want to use fuzzy unless you absolutely have to. Now there's also a fuzzy. There's also fuzzy with tokens, which does not return a datetime object. Instead, it says, here's the first element is the parse datetime, and the second element is all of the bits that I couldn't use. So if we did something like this, you would get the datetime object that it derived from it, and then everything else in a tuple of this block I couldn't do anything with, this block I couldn't do anything with, like that. Let's see. There is a few things that we can do to tweak how the parser works, like we can tell it to understand. We can give it different languages, different names for weekdays, stuff like that. Yeah, so that's parser in a nutshell. Now, as you can imagine, because of its flexibility, Dateutil parser is slow, and I've benchmarked it if you use a well-known format, you don't use fuzzy, and you compare it to using a datetime date from string format, it's about 30 times slower. Now, if you're just like processing user input, that's fine. But if you have a stream of data coming in and the date time is always in the same format, then you should do a string. You should specify the format and let the datetime parser do it for you, because it will go much faster. In fact, in the Voltron project, we were able to improve the performance of the historian's back end by replacing a call to parse with a string format, a datetime string format, and it noticeably improved the performance of the back end of the historian framework. So that's that. This is the right here's the utility that when people think of Dateutil, they're like, oh yeah, it's got this great datetime parser, and it is really nice for solving a lot of these kinds of problems. It's really great when dealing with user input. Okay, so let's look at, let's do our rule next. So our rule is a way for specifying, our rule is short for recurrence rule. And our rule is basically it creates a generator that will generate date time objects at whatever recurrence you specify. And there are, and this has lots of flexibility. So we'll look at, oh, and the recurrence rule also has its own enumerations that you need to use with it. So let's see. Let's go from date time import date time. All right. So let's create a start date of, doesn't really matter when. So there's our start date. And then let's create a list of start dates using a recurrence rule. So I'm going to have to update this a little bit. This is straight out of the documentation. I didn't do my imports the same way. So let's do our rule, and this becomes our rule dot monthly. Okay, so this says at a monthly frequency, give us 4 dates starting with December 31st, 2014. And this will show us some of the things that the recurrence, some of the edge cases that recurrence rule can handle. So let's see. I should pretty print this. Let's see. Pprint, import pprint, pprint. There we go. Much better. So you'll notice that it skipped February and April. That's because those months do not have a 31st day. So that's how the recurrence rule handles those edge cases. But if we picked a different day, we could do monthly. We could change our start date to the 25th. And then if we print out, then it's just the 25th of each month. So let's look at some of the other things that we can do here. So the main thing that we need to do is set up we need to provide a frequency. So the frequency is going to be an R rule. Is going to be one of the R rule enumerations that tells us either, daily, monthly, secondly, minutely, hourly. so that we can so that it can determine how often to return dates. Now, what our rule actually returns is an iterator. So you can actually have infinite recursive rules. So if we don't include a count or an end date, our rule will just run forever. And we can iterate through it forever. And there are, of course, uses for that. So we also have, let's see, so yeah, monthly and yearly. Now we can also specify an interval, which tells us interval equals, let's say 2, which means that it's monthly, but it's every 2 months. So then we get the 12th, or the December, February, April, and June. Yeah. Count tells us how many. Yeah. Oh, hi, Brenda.
Hi.
Hey. We can specify a week, the week start day. This will affect recurrences based on weekly periods. The default week start is got from calendar first weekday and can be modified by first weekday, until we can give a stop datetime object. We can specify the week number to apply the recurrence to. And so there's all sorts of different ways that we can build these simple recurrences. And then we can also do what's called an R rule set. So let's look at some R rule examples. Let's see, every other day. Okay, so these are pretty simple. Every day in January for 3 years. Let's see. So this one's kind of interesting. So this sets up a recurrence. That does every, let's see, every day in January for 3 years. Parser, parse. Oops. Yeah. Oh. There we go. And this is good. This is, let's see. I'm not going to pretty print that. So what this does is this gives us 3-year, a recurrence that's 3 years of days in January, every day in January. So it goes from, it starts in January 1st, 1998, goes through January 31st, 1998, and then jumps to January 1st, 1999, all the way through the month, and then to the year 2000 until it finishes on the last day of the month. So that's a more complex recurrence that you could set up. Let's see. We can do every other week for 6 occurrences. That one's pretty simple. Let's see, where's another interesting? Weekly on Tuesdays and Thursdays for 5 weeks. Oh, this should be fun. So let's do this guy. And then let's see, we're gonna parser.parse. Okay, so this says starting in 1997 on September 2nd. Oh my goodness, that's my birthday. That's kind of awesome. That was not intentional. That's just one of the examples. So starting on my birthday, oh, and this one needs to be our rule dot. We're starting on Sunday. Our rule dot start. Okay. And then we'll go print. There we go. Okay, so this gives us Tuesdays and Thursdays for 10 instances of Tuesdays and Thursdays starting from September 2nd, 1997. So that's another example of a recurrence that you could do. We could also add in like an interval count. Let's see. I think this goes right here. Yeah, right here. Interval. And we'll set that to 2. And then it's the same thing, except that it's Tuesday and Thursday, skip a week, Tuesday and Thursday, skip a week going forward. And it handles month lengths properly and all of that stuff. See if there's any monthly on the first Friday for 10 occurrences. Oh, that's interesting. Okay, so all of these examples are in the documentation. So the other thing that's interesting is that you can do what's called, not an R, there we go, a rule set. So in our rule set, let's go our set equals our, let's see, our rule dot our rule set. Okay, so this is a thing that allows you to combine multiple recurrence rules, and it basically says take multiple recurrence rules and put them together. So you can combine. You can say, okay, I have these two, I want. There's no way I can get the recurrence I want in a simple recurrence rule. I need to combine 2 of them together, or I need to exclude specific dates from date times from my recurrence. So you do that with a recurrence set. And what you do is you do an R set, and if you want to add a recurrence rule, you do R rule, and then you just specify the R rule that you want to add into your recurrence. So if you just create the set and only put one recurrence rule in it, it's the equivalent of just that recurrence rule. But if you put multiple recurrences in them, it's the same as like a union of the 2 recurrence rules. And of course, as you iterate through the set, those date times come out in order. There's also, and exclude rule, let's see, like this, where you can put another recurrence rule in there, and if there's an overlap between one of your recurrence rules and the exclude recurrence rule, it will be left out. So you can say daily for 7 days, yeah, and then skip the and then skip Saturday and Sunday. Now, there's a way you can do that with the simple recurrence rule, but maybe this might be, easier to conceptualize as a recurrence rule set. You can also add and remove, explicitly add and remove specific date times to your recurrence. So, say you want to do Tuesday, if you want to do like Tuesday and Thursday, and then you also wanted to throw like a one specific Wednesday or a Saturday in there, you can also do set our date and then specify a date time that you want to include in your set. So if we do like 1997, we'll just leave it at that. Oh, missing a month, position 2. Okay. Let's go 3,1. Okay. So now that date is part of my my rule set. And also I can exclude dates. So I can do like every Tuesday and Thursday, except for this Thursday here, and the date of that Thursday, you just exclude it. You can also, there's a well-defined format for defining these rule sets called, it's called a recurrence rule string. And it's a way of describing the recurrence using a string. And I'm trying to find it here. There's actually like an ISO format that it follows. Let's see, our rule examples. Rule set, rule string. Parse the string representation instead of recurrence rules. Okay. Oh gosh, I thought it followed like an RFC, but I don't see it here in the documentation. Okay. So, are there any questions so far? Okay. If not, then we'll talk about relative delta. So, relative delta is a way of describing a time, a difference between two date times. Now, for those of you familiar with the Python standard library, you know that there is also already a time delta in there, but relative delta handles ambiguity better than it handles ambiguity better than the built-in time delta. So, for instance, I have a date time. In fact, let's use the one that we had here before. Oh, and then I can also do list R set to get all the values out of my set. And since I only put in the one R date, that's all I get back. Okay. So if I have a date time, something like this, where I meant to be 1997. That's okay. And I wanted to say, give me the previous month. Now, there's a couple of ways you could do this. So the easiest way is to say replace place month. Well, you could say that's a and we wanted to say give us the previous month. Well, you could do a dot replace month equals to a dot month minus 1. Oops. There we go. Well, that gives us February 1st. Okay, well, that works. Okay, so now A is February 1st. Well, let's do it again. Okay, well, now it's January 1st. Well, let's do it one more time. Oh, we can't do that because our month is out of range. We can't give it a month of 0. And so Dateutil has a relative delta object that allows you to handle cases like this. And it also allows you to handle time deltas that are ambiguous. Like, I want a time delta of 1 month. Well, what does that mean? Because you can't say, well, that equals this many seconds, because it changes month to month. So relative delta allows you to do this kind of time math, and it will handle it for you automatically. So I can go A minus relative delta, DELTA, okay, I'm gonna hold on. Let's do relative delta equals relative delta dot relative dot relative delta relative. There we go. There we go. Okay. So we can do A minus relative delta months equals 1. And it will do the right thing. So, and it will point out and complain when an operation that you're trying to do is ambiguous. So, and you can add them together, you can multiply them. As soon as you try and cross like the boundary into months with your with any sort of manipulation that you're doing, if it's not appropriate, if it can't do it unambiguously, it will raise a value error. So it helps you catch those mistakes. Let's see. You can get a relative delta object back by giving it two dates. So we can do A and let's see, A minus our relative delta. So that'll give us 2 datetime objects. Months equals 1 and days equals 5. Okay. Oh, there we go. So that gives us a relative delta of 1 month and 6 days. And so if we assign that to a variable, then we can do the normal sorts of things that we would do with that. So we've got A equals January 1st, 1997. So we can do A minus D, and that gives us November 25th, 1996. So it handles all of those edge cases. It properly handles daylight savings time appropriately, I believe. It handles leap days and leap years properly. All of that is handled the way you would expect. So if you, so here's an interesting thing. So if we do D equals RD months plus 1, or months equals 1. And then we do A equals date time 1997. And then we will do January 31st. If we do A plus D, we get February 28th. So it won't automatically jump the month boundary because it knows that your intent is to move to the next month. That does mean that January 28th through the 31st, if you add 1 month to it, will give you February 28th. So we can do, we can multiply our delta by 2 times 2. And that gives us March 31st. So it really opens up.
What happens if you do d divided by 2? Does it increment by 15 days or is it 14 days?
That's ambiguous. So d div 2 is empty because you can't divide the number of months by 2. It just doesn't. It doesn't. You can't. Half a month is ambiguous.
Okay.
Yeah, it's and that's a lot of the. So if you did something like, well, let's see. Yeah, there are extra rules in place for dealing with months because of the ambiguity. So if I did something like relative delta days equals 45, that's going to give us a relative delta of 45 days. So that's 45 days, not 1 month, so many days. There's a difference. So when it's counting months versus counting days, it makes a distinction because you don't know how many days are in a month. So if you say, here's 45 days, okay, we're going to treat that as 45 days regardless. But if here's 1 month and 15 days, that's anywhere from how many? 42 to 46 days. So they're different cases, and that's the kind of ambiguity that relative delta is designed to handle. Are there any other questions? That was a good question, Gotham. Thanks for bringing that up. Okay, if there isn't anything else, I think we will call this a meeting.
I have a request, Kyle.
Sure.
Have you looked at the Numba library yet or done a tutorial on that, NUMBA?
I have not. Brandon was playing with that a little while ago, and kind of got a general understanding of it. We were the use case that we tried it with, we were not terribly impressed. Now, I'm not saying that it's not good. Maybe it was something about our use case where it's like it couldn't help us very much. But in our case, so just to speak in generalities here, because so what we did is, okay, so what Numba is, for those of you who don't know, it's a library for I don't know if you'd call it a just-in-time compiler, but it will take Python code that uses NumPy, and it will I think it will just-in-time compile it. So you're supposed to get a real performance boost out of it in a lot of the same ways that you would for PyPy, but it's designed around making your interactions with NumPy a lot faster. Does that sound correct?
Yeah.
Yeah.
It's mainly for NumPy.
Yeah, it's mainly for NumPy. So in our case, we were looking to speed up some code that used pandas, And the first step to making pandas code go faster is to not use pandas. It's to use NumPy where you can to do your actual work, because the extra layer from pandas gets in the way and slows things down considerably. So we rewrote the particular routines using NumPy and got like a 30 times speed up or something like that. It was significant. Maybe it was 12 times. I don't remember. Brandon's not on the call, so he could tell you the exact number. And then we said, okay, well, as a next step, let's take the same code that's setting up these NumPy arrays and let's put it through Numba. And in our case, it didn't seem to help at all. Now, I'm not saying that it wouldn't help in all cases, but at least in our case, it wasn't very useful. So that's all I really know about it. I would have to get into it and experiment with it a little bit. Were you interested in trying it out for
HyperNetX? Yeah. We were
HyperNetX?
thinking, yeah, because a lot of the routines we have are just set manipulations. We want to subset, get all the subsets of, and take unions of subsets. They're just set operations, which could, we've been using, I think we're just using sets right now, but I could instantiate them as NumPy arrays, and maybe there's a slicker way of doing some of the things that we're doing.
Yeah.
Because it's really slow to, I don't know if you remember when we were looking at toplexes, trying to find all the toplexes from, a given hypergraph, or even worse, trying to get the abstract simplicial complex, which is all of the subsets of the toplexes, trying to, create a generator for those, because it's just a huge number of things. Right. And I'm just wondering if we could improve performance if we use something like Numba. Cliff was asking, Cliff Joslin was asking about that, and he just discovered it. And so I said I would try to implement it, but I wanted to know what your thoughts were.
Well, yeah, for sure. Any sort of compiler or as long as it's still in sets, any compiler or just-in-time compiler that you use is not going to make it go any faster, because you're still ultimately, it'll go a little bit faster, but ultimately you're relying on the performance of the Python set implementation. So that's the big thing. Now, if you can come up with a way to, my advice based on my experience helping you with that project would be to closely look at why you're using sets and what you're using them for and how you're using them. I mean, the sets in Python are pretty efficient in that, you can do adds and removes and test membership all in constant time on average. But when you start merging sets together and doing stuff like that, then it becomes O of n times n, it becomes O of n, where n is the number of things that you're trying to do a union on and stuff like that. So it's like, how are you, I would look at how you're using the sets, and if there's a way that you can do it with, arrays and or NumPy in general, you might have to change how your algorithm is implemented, kind of like what we did with the what was it called? With
Flask-Ada, that project.
Yeah, the Flask-Ada, where we had to think really hard, like, okay, why are we building this set in the first place? And then our big wins, for those of you who are not familiar with this project, our big wins came from figuring out what code paths we could eliminate at runtime by reducing the size of reducing the size of the input and removing stuff that we already knew what the output was going to be from it, and it added a lot of extra steps that were that were therefore unnecessary.
Right. So maybe I should maybe just look at that first. And so you would not recommend trying. You don't think Numba would really help?
Not as a first step. That's like when you've squeezed everything else you can out. I mean, generally in programming and computer science, your big wins for efficiency almost always come first from improving your algorithm. Yeah, and but it kind of stinks because that's the hardest thing to do. But it's like, if you take something, you need to take it from n squared to n. That's going to be a bigger deal than on average than moving it from pandas to NumPy or whatever. Although that would be your next step.
Okay.
Yeah.
All right. Thanks.
Yeah. So, all right. I don't have anything else. And if you're not familiar with these projects that Brenda and I are talking about, they are open source on GitHub. Well, I don't know about Flaskada, but
HyperNetX is up there.
Yay!
Yay! Yep,
I'm so excited. I'm so excited.
Yeah. Me too.
So yeah. Okay. All right. Well, if there aren't any other questions related to Dateutil or otherwise, I think we'll call it a meeting.
Thanks, Kyle.
You're welcome. Good to talk to you, Brenda.
Yeah, you too. Bye-bye.
Bye.
Thanks, Kyle.